Greetings to all. Welcome back to the course on power electronics using MATLAB. So in this course, we are into the lecture where we will be understanding the Mosfet. So there are different type of transistors which are being used all over the electronics industry. So first is bipolar junction transistor, which is known as BJT. Another one is IGBT, which is popularly known as IGBT, but its full form is insulated gate bipolar transistor. Another one is field effect transistor. Out of these two type of switches, which is IGBT and the MOSFET. What is the MOSFET? MOSFET is a subset of FET transistor group, which is metal oxide semiconductor field effect transistor. So these type of switches, MOSFET and IGBT, are mostly used in the power electronics, which is related to the electric vehicle industry. So also we can say that these type of transistors, that is IGBT and MOSFET, are mostly used for high power application. High power application means which has a higher power rating, and BJT is more or less limited to a low voltage or a very low power circuits. So first we'll be taking up the metal oxide semiconductor field effect transistor, which is popularly known as MOSFET. So we will be not going into the physics of this. So we'll be not going into the physics of MOSFET. So what we will be doing, we'll be going through the what are the characteristics which are very important for the MOSFET, and what are the type of MOSFET, and how we can select MOSFET on the basis of the application. So this is more of a practical video where we'll be selecting a MOSFET, where we'll be knowing that how MOSFET are selected and which type of MOSFET is better for which kind of application. So usually a MOSFET consists of three things. One is gate, one is drain, and one is source. So this is drain D, this is source, and this is the gate. Gate, why it is named gate? Because as soon as we apply voltage on the gate, the drain source channel starts to conduct, as shown in here in this figure. Here you can see that this is the gate where the pulses are given, the positive negative pulses, and as soon the positive pulse comes to the gate circuit, this becomes conductive. Okay, so the channel connects drain and the source terminal, allowing current to flow when activated. That means MOSFET will be activated by the gate voltage. That's why MOSFET or the FET family is known as the voltage controlled switch, because as soon as you give voltage to the gate, it starts to conduct. So these are also of two types, enhancement mode and depletion mode. So in enhancement mode, we require positive gate voltage, and most of the switches which you will be encountering in the circuits or in the power electronics will be of enhancement mode. So we will be sticking ourselves to the enhancement mode MOSFET. So the gate pulse which is given to these kind of switches are positive VGS. VGS means gate to source voltage. This is known as VGS. So the VGS will be positive in the enhancement mode MOSFET, or the MOSFET which are working as in an enhancement mode. So MOSFET basic construction is like this. There is a N channel, there is a N substrate, or the N type of semiconductor is there, and in between there is a P type of semiconductor. As soon as the positive voltage is given to the VGS, there builds a channel, that is N type of channel, or the electron gets accumulated here in this P channel, and this makes the current to conduct through that channel. Before that, when VGS is 0 volt, when this is 0 volt, there is a gap between these two N substrate, the top N substrate and the bottom N substrate. As soon as the VGS positive voltage is given, there becomes a channel, and that channel starts to conduct the electricity through it. That channel is known as enhancement channel or enhancement mode, the channel which is built due to the enhancement mode. So this is the basic characteristic of the MOSFET, where as soon as the drain to source voltage is increased, the drain current also increases, but it gets saturated as soon as the VGS is more than the V threshold. So there is a basic, or there is an elementary voltage above which the drain to source becomes saturated. That region, that saturation region, is used for the switching. So MOSFET on the basis of VGS voltage can be worked in a three stages. First is there is a threshold voltage, V threshold. Whenever the gate voltage is less than threshold, there will be no current conduction. No current will be flowing through the drain to source. So this is drain, this is source, and no current will flow if VGS is less than VThevenin. As soon the VGS become greater than VThevenin, there starts a conduction of current. and it gets saturated when VDS is greater than VGS minus VThevenin. So this is a condition which allows that channel to build fully. That means for switching purposes, we have to keep MOSFET in the saturation. So one thing which you should be learning from here is that for MOSFET to work as a switch, V gate to source should be more than V threshold. And for most of the MOSFET which will be showing you through the LT spike model, we will be using a 12 volt. So the threshold will be somewhere around say 6 or 7 volt. So we'll be breaching that threshold level and we'll be switching the MOSFET on. So we'll be working as here only. Always as a switch, MOSFET will be working in a saturation region where the channel is pinched off. Pinched off means the channel will be fully formed. Which channel we are talking about? This channel. This channel will be fully formed, and because of this, the current will be flowing. The current will be flowing from here to here and through this. So this is a pinching off of channel. So this channel will be fully formed when VGS is greater than V threshold. So this is the condition for MOSFET to work as a switch. So we'll be working, the MOSFET will be in the saturation region for work as a switch. So there are two type of structures of MOSFET. So the practical MOSFET do not look like this, which we have made here. This is for the study purpose only, that MOSFET has 3 channel, 1, 2, 3. One is 2 of N and 1 of P. But basically MOSFET, the practical MOSFET looks something like this. These type of MOSFET are known as the planar gate MOSFET. What happened here is we have 2 N layers, 1 N plus means the doping is very high here, and minus means doping is slightly lower here, the N type of doping. Then there is a P substrate, or this is a third channel, and then there is a fourth N channel. So this is 1, 2, 3, 4 channel. So actually the real gate or the real MOSFET which are manufactured in the company do not look like as if they are not simply made like this, that you have 2 N channel, one N and 1 P. So they do not look like this NPN type. They have a very complicated structure. So this kind of MOSFET structure is known as planar gate. Okay, so they have a gate above it and a simple gate which is just stick outside the MOSFET. While in a trench gate MOSFET or the U MOSFET, you will see that the gate is imbibed inside the substrate. So here also there is N plus 1 channel, 2 channel, 3 channel, and this smaller one is 4th channel. So there are also 4 channel here and 4 channel here. But there is a one big difference. The gate here is simple plain. That's why the name planar is given. And here the gate is trenched into the substrate. So that's why the name trenched or U shape is given, because of this U shape. Because of this U shape. So there are two type of structural difference in MOSFET. One type is known as pi gate MOSFET, which is simple planar, or another one is U MOS or the trench gate MOSFET. Both the MOSFET have different practical applications. So which parameter are important for MOSFET? So there are 3 basic parameters which are very important when selecting a MOSFET. First is the switching speed. What is the switching speed of MOSFET? In how many millisecond or in how many microsecond the MOSFET gets on and off. So this defines, so if for example, if a MOSFET gets on in 1 microsecond and it gets off in 1 microsecond, then how to find the frequency? 1 divided by this time, 1 microsecond. It is 1 megahertz. So that means the frequency which the MOSFET can be applied, or the PWM frequency with the MOSFET which we can apply to the MOSFET for the switching, is 1 megahertz. So usually this is a very high frequency. So usually MOSFET work in a range of 100 kilohertz or more than 100 kilohertz. Some MOSFET can work in a around 1 megahertz, which are smaller in size. But there is another category of MOSFET which is silicon carbide MOSFET, which has a very higher frequency, or switching frequency is very higher. Another thing which is important is switching losses. So because of this structure, there is a resistance offered by this MOSFET. How the resistance is offered? Every gate will be offering some resistance. this is Rn minus, this is Rn plus. So the total resistance is known as the R on, R drain to source on. So what is the RDS on resistance? And this is very very important because this RDS on will be creating losses during the on period. That means when the circuit is on, that time it will be creating a problem by dissipating the power. So this is also very very important, RDS on. So one thing is switching speed, another thing is switching losses, which is dependent on the RDS on. And third is the thermal performance, how the MOSFET is performing at 100 degree, 150 degree, or is RDS on or the resistance is increasing, and if it is increasing, how by what percentage it is increasing. So this is also very very important. So these three are the basically the terms which we take care. And another one which I have not written here is the voltage rating. Voltage rating, that means what voltage a MOSFET can block during the switch off period. Okay, so these are the 3-4 things which are very very important. So what is the important parameter? So out of this, RDS on is a very very important because it affects the efficiency, because of the RDS on there is a losses created during the switch on period. So this characteristic becomes very important, the RDS on. So here you can see, for example, many middle and high voltage RDS on. So there's a two type of trench gate MOSFET and the planar MOSFET. So both have a different RDA or the RDS on. So here the RDS on in planar MOSFET depends on the R drift. Drift is a this region resistance. So every region has a resistance. This is 1, 2, 3 and this one is 4. Here also 1, 2, 3 and this one is 4. So these are the resistance. So RDS on its planar MOSFET depends on the R drift, and RDS on here also depends on the R drift. So for many MOSFET, for any application having a voltage rating of 250 or higher, we'll be using planar MOSFET, and anything voltage is less than 250 volt, we'll be using trench MOSFET, because the resistance offered by planar MOSFET in higher voltage rating is lower, and by the trench MOSFET in lower voltage rating is lower. So RDS on affects your choice of MOSFET. So if you are working on an 800 voltage system, you will be going with the planar MOSFET or the pi MOS. If you are working on a 48 volt system and you require a MOSFET, you will be going with the UMOS. So usually the VDS defines how you will be selecting the MOSFET. So what are the advantage and application of the MOSFET? So here there is a comparison of trench gate, planar MOS, and there is another is a super junction. This is a very very advanced MOSFET which is being made by some company. So this SJ MOS, these characteristics which I have taken here is for the company known as Toshiba. So this is a MOSFET which they have made, SJ MOS. So here the on state voltage capability is up to 250 volt, up to 900 volt and 600 volt or higher. Here you can see that the high speed or the switching speed is good, here also good, and this SJ MOS has a excellent switching speed also, excellent voltage capability also. So here you can see that the SJ MOS from the Toshiba company, this is also made by another company also, but this is a better choice when we are comparing with in the terms of voltage, current, speed, and what is the reverse voltage which it can block. So where the application is for the small battery application, you can use trench MOS, because battery application usually the voltage is lower end. For small to medium capacity converters, you can use DMOS, and for medium to large capacity, where it can be a driver or it can be a very very high motor drive, you can use the SJ MOS or the super junction MOSFET. So this is how you create the you select the type of MOSFET. So this is all about the MOSFET, and this video is related to the practical application of the MOSFET, or how you can select a MOSFET and what are the important parameters which affects the selection of MOSFET. So this is how the RDS on resistance is decreased or increased. So this is more of a designing constraints, or the how the company reduces the RDS on by affecting the by reducing the channel width and other things. So for example, we can use here how to improve our channel. So by shorting the channel, means if a channel width is say 2 micrometer, you reduce it to 1 micrometer, you will be reducing the resistance of the that channel. So similarly, there are many things which the company does. Thin wafer technology, the wafer size is very thin. The silicon wafer, which we, this wafer means the silicon wafer or the semiconductor wafer. So if there is a thin wafer, the resistance drops. So this is how the companies are approaching to the RDS on, because it is one of the single biggest factor apart from the switching frequency, which is creating problem or which is creating a bottleneck to the efficiency. So if a converter is working at a 95% efficiency and you reduce the RDS on to half, the efficiency can be increased from 95 to 97, 96%. So this is how RDS on is important. So this is all for the MOSFET video, this video. So what we'll be doing next is we'll be showing you one application that is we'll be using a MOSFET in a boost converter, and we'll be showing you how the MOSFET is working, and we'll be using a real MOSFET which you can buy from a shop also, an electronic shop. So this is all for this video. Thank you.